Well, hello, SINUMERIK Nation, and welcome to Simply SINUMERIK Live. I'm your host, Chris Pollitt. Today I have a special treat for you guys. Today, we are actually standing in the Siemens Technology Application Center in Elk Grove Village, Illinois. I'm actually in front of one of the Track BMC7 SIs that they have here. As well, there's a lot of other equipment. You're not going to get to see it yet, but soon we're going to start moving around through the shop, and you guys are going to get to experience it in upcoming YouTube Lives. So keep an eye out for that. I'm here because we're going to do a little bit of probe calibration, but I'm also going to introduce a great friend of mine and colleague, Dan Struble. So Dan, come over. Dan, SINUMERIK Nation, Dan.
Hi everyone, hello SINUMERIK Nation, thank you for having me. We're here standing at the TAC where I work at, underneath Chris, and we're going to get into some fun things about probes.
Great.
We're going to talk about probes today.
All right, so I'm going to leave it up to Dan. Dan's going to kind of guide us through the steps of probe calibration and all the fun things that go along with that. I'll be on the side to support him, and then we'll jump back in and we'll answer some questions at the end. So Dan, it's all yours, buddy.
Thank you, Chris, for the introduction. So we are here at the TAC and we are going to talk about probe calibration. So everyone buys a CNC machine and they have a probe and they want to know how to calibrate that probe here on our control. So we're going to do that today. We're going to talk about what is needed for a probe calibration. We're going to talk about the things and tools that are needed to do it, and we're going to get into doing it right on the control and seeing the user screens and how we actually walk through from calibrating that probe. In order to calibrate the probe, we're going to need a few things. First things we're going to need is we're going to need some type of calibrated or ground block, a nice surface to touch the spindle face to this, to the top of this, to set G54 0, so we have a known location in the machine, just for setting the length of the probe. As well as we're going to need an indicator to indicate the stylus in and make sure that the runout is running true to the spindle. And we're going to need a ring gauge with some magnets. Okay, definitely going to need a ring gauge with some magnets. So those are some of the things. We got a ring gauge here. So ring gauge here that we are going to need to calibrate that stylus and the diameter. A couple other things that you could use when calibrating a probe on ours, not necessarily, these are the basics. We went through the basics. These are the only things that we need to kind of walk through and calibrate on our machine. Some of the things that might make your life a little bit easier that we're going to talk about later is using a reference tool or a test bar. And what the difference between that is if we look in on this tool is ground to a certain gauge line. Okay, that's what sits to the gauge line inside the spindle. There's a couple benefits to this, but this is a tool that you could use where you come down and touch that block, and then we have that known gauge line, and then we set that 0 on G54. And the last thing that we'll kind of get into, again, too, is something that you can do if you have a sphere. You could calibrate using a sphere on ours, too. And we have a user screen to go through that as well. We will talk about that once we get through kind of the bare bones of how you would set up and calibrate that probe. So we can kind of get into that. So we're going through what it is and the tools that we need and how we're going to set up a probe. Well, the nice thing is, and what I want to keep and continuing to do this throughout every one of these kind of YouTube lives, even these short videos, is kind of give you a little documentation. So what I've done is I've gone through and prepared a document that goes step by step what we're going to do today, okay? And this is going to be in the description, so you can download that and save it for later. It's really nice. It's really, really helpful. So we're going to get into setting up and calibrating the probe. So we're going to do that. Here, we're going to come into, and the first thing we're going to need to do, and this is the first thing that we have in our document, is we're going to make sure G54 is active and there's nothing active in the spindle. So first things first is we're going to come to our TSM page and we're going to hit 0, right, and make sure that there's nothing in the spindle. So we're going to cycle start that. So it's going to clear the spindle. The next thing that we're going to do is we're going to set and make sure G54 is active. It already is active, but we're going to do it just a habit. So we set G54 is active, right? Cycle start that. Now we have G54 active, and we have nothing in the spindle. So this is the two keys. We have nothing in the tool page saying that there is anything, no offsets are being active, and we have G54 as our tool, our work offset being active. Now we're going to get our ground block, whether it be a 1, 2, 3 block. Here I have a little bit bigger so my spindle can come down and touch the top of it. So here we're just going to position the spindle and get it down and touch the surface of the spindle to the surface of the block, and we're going to zero out and set G54 0. So we have increments on this machine, so I can bring it down and get it really close. Set it to a 1/10. Once she squeezes in there, then you can set G54 0. So we're almost there. There. So now we're kind of snug under there. I kind of feel that you can actually get the block in underneath the spindle. Once you do there, you're going to go to and set work offset. And here we're going to say XYZ 0, kind of know where that block is that you set it. So here we're showing 0 now. Now we're 0. We're good to go for our G54. So now we have a known plane that's 0 to set our length. Okay. Once that's cool, kind of the tip that I have on doing this a couple times throughout my career on different machine tool builders, get the spindle out of the way when you're starting to touch buttons on the screen. This way you don't mash the spindle into anything else around it. So that's kind of one of the things that I would do. Just kind of get out of the way before we go into the next step. The next step now is we are going to make a new probe and load that probe into the magazine and put it in the spindle, and we're going to check run out before we set the length. So we're going to go to the tool offset page here, and we're going to create a new tool. So I already have one created in here. I'm going to unload that, right? And I'm going to create a new one, okay? One of the things that I always do and always talk about for SINUMERIK and Siemens Controls is that we're going to go to the bottom of the offset page and we're going to get that new tool button up on our vertical soft keys. This is kind of what I would say is the practice on all of them because they usually work on all of them. Go down to the bottom of the screen, find an empty spot, put a new tool in. This is good practice. Other machine tool builders and other machines, you might be able to put that new tool in any magazine pot. I don't really like that practice because then it's up to you to make sure that you put it in that pocket. So this way, this is the foolproof. You're not going to load the wrong tool, okay? So new tool. We're going to go to special tools. That's where probes are at. And we're going to load a 3D probe. Put a 3D probe in there. We're going to give it a name. We're going to say 3D probe 1, right? And then once we get it in there, we got to add some things. So a couple things that we need to do is we need to give it some known length, right? We got to give it some known length. So I got a tape measure here. And roughly all I'm going to do is just kind of get the gauge line to the tip of the stylus. I'm running at like 7 1/4 on this probe, and that's all I'm going to put in there. So I'm going to go back to the control, and I'm going to put in 7 1/4. Oops. 7 1/4, and then this ruby is 6 millimeters. What's nice on our control, you don't have to do any math. You just say it's 6 and then as long as you're converting into inch, you're going to say 6i, and it converts it for you. So now once we have that, we can hit load, and it'll put it into our magazine. It's going to choose pocket 10. So now once we have it loaded, we're going to go back to our TSM page and load our probe. I'm going to go to magazine 10 and say OK. Cycle start. So once our probe is in the spindle now we can put the probe in there. Again, this is the step that we're going to actually go and we're going to tram this stylus in. So one of the things in the document that I've provided in the description, if we look at it, is we have kind of a layout of the inners of a probe body. So here we have 4 kind of positioning set screws that kind of go around the probe body and the tool holder, and then we have 2 that anchor it to the tool holder. So what I do is I kind of snug the 2 anchors tight, and then when I get my indicator on the stylus, I use those 4 set screws to fine tune it, and then I lock it all down once I'm pretty happy with it. One of the things I would say is usually kind of get it within 2 tenths run out would be kind of the goal. I always try to get it as close as I can to that. The nice thing with our control is we have the ability to comp that as we calibrate it. So that's the nice thing. So in the document, we have the ability of doing that. Here, we're going to get the probe in there, get an indicator set, bring it up to the stylus, test the run out, and see if we're good. And then we're going to go right into calibration. So what we're going to do is grab our probe, open the door, put our probe in, get our indicator, bring it down, and then here, once we get the stylus on there, to save time, you would basically get it on there and then move the set screws to get it in here. I set this earlier today so that it is running true. It's actually running on 0, so that's nice. So once you get the run out done on this stylus, you're good to go to start going into the calibration page. So here, since we have the calibration already ready to go, we're going to now bring it and just be, I'd say, about 1/4 inch above the block, and we're going to go into the calibration cycles. So once we get it just above the block, we're going to go into the measure workpiece. Calibrate probe is where we're going to be. We're going to go to the calibrate probe. Now we're on our block. Calibrate probe. We're going to do length now. And since we set that Z0, we have the ability now to know where that 0 is to find out the length of the probe. So here we're just going to hit cycle start. Once we hit cycle start, she's going to come down and touch the tip of the top of the block, and we're going to see the length change here. So we see the length change was 7 1/4. We actually changed to 7 400,000ths. So now we know the length is calibrated. We can move on to the radius. So once that's calibrated, we're good to go. Get in the habit of when you do each one of these steps, get the probe out of the way. Broken styluses, just taking components out. So this is kind of a tip of doing this a couple times. Getting that probe out of the way. Then we're going to use the stylus. So I'm going to get a rag, wipe the table, wipe the bottom of our...
Here you go, sir.
Thank you.
Gonna feel like Vanna White over here. And the letter is J. Yes, we have a J.
So here we're gonna just put it on the table, get it secured, and then we're gonna eyeball the probe in the center. And each one of these ring gauges has a known diameter, and that's what we're gonna put in the field.
What if I don't have a ring gauge? Are we SOL, or is there anything we can do?
One of the things, if you didn't have a ring gauge, that I would do if you're in the field is hopefully you have some type of measure device, maybe a caliber or a mic, and I would take a block of steel and machine that, and then use a mic, preferably a mic, and mic the hole, and then that could be what you could use as a ring gauge. We know this is a measured artifact to the diameter that's written on the ring gauge, so that's what's given you. If you don't have a ring gauge, make your own, but make sure you have the proper ways of validating what that diameter would be.
Yeah, I think we've all done the crude method just to get a jam to get things going in the past. But I would absolutely agree. Long term, you have to go off of a qualified artifact.
So we go to the diameter screen now, and now we have a field that we enter in that value. So this value is important, right? If you're ever out there and you cannot enter in that value, let's say you go to your machine and it won't let you enter this value, there's an MD. I specify that MD in the document that you can download in the description. The ability here is setting it to -1. Now you have the ability to put in the diameter of whatever ring gauge you have, okay? So the same thing goes here. Once you put the diameter in, hit cycle start, and she's going to go around twice. Once to find the center of the ring gauge, and the second to then start to take the measurements of each hit. So we'll do that. So now you can see that we have a change in our diameter. So now we have the stylus calibrated, and we are good to start utilizing this part probe to start measuring our G54 work offsets, and then even taking measurements and using our measure cycles on our machine. One of the things that we can also do is we can actually start to utilize a sphere too. This does the length and the radius in the same time. If you have a sphere, you can use a sphere to calibrate your probe too as well. I think that might be a little bit more kind of elaborate. Not everyone has a sphere laying around. This is kind of the bare bones way of setting up a probe. It seems very easy, the couple steps, right? And then also, like I said, wrong one. We have the probe document that we have that you can download into the description. That gives you the ability to look at this and kind of download it for your own reference. And then if you have any questions, you have the ability of doing that and kind of going through there. So I think now would be a kind of a way to kind of open up to any questions that we might have that might have come into the chat, or if we have some questions that might have come in. So Chris?
We do have some questions. Great job, Dan. Let's take a look. Oh, let's go back to the chat because there were a couple of things here. Some just great communication from everybody. We certainly appreciate you coming and stopping by for the event. So let's go through some of the questions that we got that came in. So how important is it to adjust the run out in the probe? I mean, you were talking about 2/10. So how critical is that?
So I would say it is not as critical on our machine, on our control, because we have the ability to comp that. We're taking into that discrepancy that you would say if you're having it, as long as that you are calibrating this probe. If you have a little bit of more run out than you normally would say, the control will measure that because it's measuring on each one of those hits that it takes in those 4 quadrants.
why would I want to calibrate to a tool standard versus a spindle face? Because you worked off spindle face, you mentioned a calibration tool. What's the benefit to me going that direction versus spindle face?
I'd say one of the things is this gives us the ability to now work off gauge line for all our tools and our strategy of how we're going to use our shop. So not only for the probe, that we know where that gauge line is in every machine, we then know we're going to keep that strategy for our tools too as well. So that might be where we will actually utilize gauge line for our tools. So the next thing is that we would set up our tool probe for gauge line, and that way if you take a tool from this machine to the next machine, that tool is going to be the same on every machine in my shop.
And is it true that if I want to use a presetter, like this great Heimer we just got over, well, that's another thing we're going to get to show you in the future, but is it true that I have to use gauge line once I use an external presetter, or can I still use spindle face?
Yeah, you have to use gauge line once you use a presetter. So if you're going to introduce anything third party to the machine that is going to measure your probe or measure your tools like a presetter, you're going to need to use gauge line.
And how would you explain what gauge line is to the audience? Because I don't know if a lot of people really know. I think a lot of us have heard the term, but what does that mean, gauge line? Like, what is it? Where is it on the tool?
It's actually in the spindle, so it's the end of the gauge line in the spindle taper that's ground into it, and so that is what is going to dictate what that is, the variation. So there's actually kind of a gap from the tool to the spindle face because it's actually coming off the taper contact in the spindle.
And is that gauge line the same if I have maybe a big plus machine?
Yes. Yeah.
Good. All right. Let's see what else we got here. Okay, this is an interesting one. So I have a machine that every time I measure, the X and Y moves just a little bit, kind of jumps on me before it actually takes the measurement. Any idea what's causing that?
Yeah, so there's two types of commissioning probes for our control. One is the ability to what we did today. So we didn't find the center of the ring. We just basically eyeballed it and it went around twice. And what it did around the first time is it found the center of the ring, and the second time it actually calibrated the stylus, finding the measurement of the center of that radius to the edge of that hit. The other type or other way of setting our control is where you actually bring an indicator and a coaxial and indicate in that ring. And when you indicate that ring in, you're getting and finding that known center of that ring, and therefore you are now then going to calibrate off that. So it goes right into measuring. So whatever deviation that you have from the center of where your probe was into that ring is what that deviation you're going to see every time you see that little bit of kick. So if you don't have that probe center perfectly in the ring gauge when you go to calibrate, that's what that deviation is.
Gotcha. So basically you're saying, for his case, if he indicates in the ring gauge and then calibrates, making sure the probe was dead center before he turned on calibration, that'll at least fix it.
Correct.
Okay, cool. There is another trigger you'll notice. If your machine's set up for that, it'll only ever take one measurement around the ring gauge. If you watch ours, it actually took two. Yep. First one is strictly to find the center of the ring gauge. Second one is to measure all 4 trigger points.
Correct.
Cool. And then we had one more. Oh, why after calibration is the probe ball not 6 millimeters in the tool offset tape?
So if we looked at our offset screen here, and I'm not cutting it off.
Yep.
We don't have perfect 6 millimeters on that stylus, and it's because it's actually taking into consider the trigger in the probe, that lag. So there's a little bit of lag in the probe, and that's taking into account that trigger. And we want the control to do that because it's going to now predict that lag on every hit. So we know that the triggers inside the probe is happening, so we want to know what that is happening. So that's why we're not getting perfect 6 millimeter number.
And one of the things to take into account that's super important with that's also why you always want to make sure that your measuring speed while measuring is the exact same speed as your calibration speed. Now there are some different ways to set up the machines. The way we set this machine up, you can adjust the speed during measuring. So no matter what you put that override, you probably didn't notice it, but this machine was running at 10 inches per minute during that time. If he put the override at 10%, it still would have been running 10 inches per minute.
Yeah.
Did that on purpose. But it's a machine parameter. Your machine may allow you to adjust the override. So that means if you crank your override up and down, that lag on that trigger switch will change, so your measurements will change. So if your machine is like that, it's okay. Just make sure you always have the override on 100%. And whatever you calibrate the speed at, that's the feed rate you'll be doing the probe. Great. I think that covers all the questions. Again, awesome job. So what you guys are going to see moving forward, certainly I'll continue to make content in my studio out in New York. But Dan is going to start to make a lot of content here from our Technology Application Center right here in Elk Grove. We have some really cool technology. Certainly the 4-axis machine that you saw here. To our left, you can't see it out of frame, but we do have a DMU 50 DMG 5-axis machine. So we'll be able to do a lot of real fun content there, talking about setups and all kinds of crazy stuff in the more advanced world. To my right, we have some digital twin technology in our DTM. So we'll show you some of that. As I mentioned, we have a Heimer presetter. We're going to get into using presetter. Show you guys maybe how to take advantage of a little more advanced setups by introducing a presetter in your shop. And we're going to continue to expand it from there. So, Dan, great job.
Yep. Thank you.
Great to have you on board now with the YouTube Live. It's official.
Yep.
You can do it. No excuses. I expect to see a lot of videos. Thank you, everybody, for joining us, and we look forward to seeing you next time. So with that, have a great day.